Hi, Karan. Thanks for joining us today, Karan.
Hey, hi Vijay, how are you?
Fine, Karan.
Okay, is my audio coming good?
Yes.
Yeah, there could be some latency in the video, I think, and
Yes. There is a
looks like
some.
looks like
Yeah.
yeah, it could be a restream issue.
Yes.
But anyways, I think we can. So how it's going? How it's going so far?
Yeah, it's going good. So this is our first attempt.
Yeah,
Probably we can.
congratulations for setting up this community around
Yeah.
and that you guys are doing a good job. I
Yeah.
can see already a lot of good speakers and a lot of good talk coming up, and
Yes.
so yeah, I really looking forward to it.
Yes. So probably you can share your session for the Kubernetes clusters. So basically, they will get more idea how this works, everything. Correct.
Yeah, so my session is like I would rate it as advanced 303 30301
Okay.
where I'm going to talk about multiple OpenShift clusters and Kubernetes.
Okay.
So I'm going to share my screen and I'll let know if you guys are able to see this.
Okay. Yeah.
So
Yes. We are able
is
to
it
see.
coming good to you?
Yes.
So you're able to see my GitHub,
Yes.
right?
Yes.
And one more and now this one is the slide deck, right?
Yes.
Okay, and one more is I need to show you also my terminal. I need to make sure that it's here. Hold on. Sorry, so many tabs and so many. It's
No
always
problem.
difficult.
As a technical,
Uh,
we have to bear with this.
and this one is my shell. My shell is visible properly.
Yes.
And how about the font size? Do you want me to increase or is it good?
Can you bit increase? Uh,
Okay, then I need to increase it like. I hope this is good now.
yes.
Okay, so I think I can take it from here, Vijay. Thanks so much for the introduction. So, or anything else you want to add before
Yeah.
I
First
start?
of all, you introduce yourself, Karan, to everyone. Many of
I
people
will,
don't know about you. So
yeah, I will definitely introduce myself. And so yeah, I'm Karan Singh, senior principal architect and developer evangelist at Red Hat, and I work for Red Hat developers team at Red Hat. And in this talk, we're going to talk about distributed deployment of microservices across multiple OpenShift Kubernetes clusters. So as I mentioned before, this could be a slightly advanced topic. So if you guys are not up to speed with Kubernetes, so don't worry, I'll give you some resources during the or maybe at the end of the presentations, which can help you start your Kubernetes journey or you start your OpenShift journey. So bear with me if these things is slightly complex for you. um all right, so as I mentioned, okay, yep, I work for Red Hat and in the developer evangelist team. I do write few blogs as well, so you can follow me on Medium and as well as on LinkedIn if you want to know about Kubernetes and cloud native technologies, distributed systems, and design, which is something which I really love to do. Okay, so now jumping on to the subject for the day, which is distributed deployment of microservices across multiple OpenShift clusters. So let's first of all go take a step back and understand what I mean about this long title. So I'm pretty sure that everybody on the call or maybe who will watch this restream later on, they might be aware about microservices application, like what are microservices and how why people use it. So I assume that's the basic. Um, OpenShift or Kubernetes, and maybe when I say OpenShift, OpenShift is Kubernetes and Kubernetes is OpenShift. Right. So when I say these terms together, so just assume that I'm going to speak about Kubernetes because OpenShift is an enterprise distribution of Kubernetes from Red Hat, and it comes with a lot of goodies. So in this demo, in this presentation, we're gonna use OpenShift clusters. right? And we're going to use multiple OpenShift clusters running on 3 different public clouds. So we're going to use one from AWS, one on Azure, and the third one is on IBM Cloud. So imagine we're going to have 3 OpenShift clusters, and we're going to deploy our microservices application distributedly across all the 3 clouds, and we're going to use them as a single application, right? So this is kind of a pretty decent thing. All right, so let's begin with the cloud. So what is, you guys probably know what is cloud, so I'll not go into that, but what is multi-cloud, right? Multi-cloud is, as the name suggests, multiple clouds from multiple private or public providers, right? And for multiple workload and tasks. So you can use, deploy application on multiple clouds and from multiple different providers. However, one interesting point in multi-cloud is that there is no interconnectivity between clouds or interoperability between the clouds. So right, like there would be no direct connection or private connection between AWS cloud and Azure cloud and let's say Google cloud or IBM cloud or maybe someone else, or even OpenStack cloud if you're running on premise. So there would be no direct connectivity to it. There would be connectivity over the internet, which is open, which is insecure, and which is full of latency. So right, so multi-cloud by definition is multiple clouds from multiple public or private providers, which does not have interconnectivity between them. So how on earth, how on this world we're gonna use multi-cloud as our next cloud provider or our next cloud strategy, right? So before we go into that, why do one care about multi-cloud? Okay, great. AWS is great, Google is great, or others are great. But why should I care about multi-cloud as my ID strategy, right? One of the important points that came up from a lot of surveys is that avoiding vendor login. So if you are putting all your resources just let's say on AWS or maybe on Azure or maybe for the sake on other cloud providers, you are kind of locking yourself into a vendor ecosystem, because tools on Azure will not work on tools on AWS. So kind of you're logged into this, right? That could be the number one reason for using multi-cloud. And then competitive pricing. If you are just using a single cloud provider, you could not leverage the competitive pricing or flexibility of pricing from other cloud providers, because this is a cloud war, and every cloud provider with every quarter coming up, they slash their prices. And if you're logged into a one single cloud provider and you cannot move to a different cloud provider, you are kind of losing money on the table. So competitive pricing is one of the good reason as well. High availability and resiliency. At least I have seen this many times when I use cloud providers in a specific region at a specific time. If you try to launch a lot of resources, you get such messages that, hey, currently we are over capacity and we are not able to launch your specified instance in your specified region, right? I've seen this message multiple times. So what you need to do is you need to either wait or change the instance type and kind of, or maybe use a different region that you don't want. So if you have a multi-cloud strategy, let's suppose if AWS Mumbai is running out of a specific instance type, then probably you can go and open up your Google console or maybe Azure console and launch compute and resources on other cloud providers in the same region. So, and if one cloud provider goes down for a specific reason, your business suffers. So it's good that you have your business apps running on multiple cloud providers so that you can take advantage of high availability and resiliency. And of course, flexibility and scalability comes along. So these are few reasons why people choose, enterprise companies are choosing to go with multi-cloud, right? So, but multi-cloud application deployment is a complex task. Imagine a world where you are a DevOps engineer or you're a developer and you are tasked to deploy an application on 3 different clouds, right? It's a daunting task. It's a complex stuff because different processes and tooling exist for each cloud providers. The API calls on Azure will not work on AWS or maybe on IBM. So you need to have a single common application platform which spans across multiple cloud providers, so that you as a developer, you as a DevOps person, you can use your familiar tools and practices to deploy application on top of three environments. So guess what? Kubernetes or OpenShift simplifies this journey to multi-cloud. Kubernetes is the de facto standard for container orchestration, and it's readily available on almost all cloud providers, and there are a lot of distributions available. OpenShift is one of them. OpenShift is Red Hat's distribution to Kubernetes, which provides you enterprise grade Kubernetes. So the way it works is you will have OpenShift on across as the base platform across all three cloud environments, which kind of abstracts away the complexity of a specified tooling and APIs from respective cloud providers. So as a developer or DevOps person, you just need to know Kubernetes, or you just need to know OpenShift for that matter, to interact and deploy and manage your application. So kind of OpenShift solves your multi-cloud challenges with respect to your heterogeneous cloud environments. But there are still more challenges. It's not done yet. Internetworking between multiple Kubernetes clusters is a complex stuff, because we can definitely connect application 1 on cloud 1 can definitely connect to application 2 on cloud 2. However, the connection would be insecure, and it would be over the internet, and it would be slower. So interconnectivity, cluster networking is a complex stuff which needs to be solved between to just gain the full power of multi-cloud. What comes to the rescue is Scupper. So Scupper simplifies multi-cloud cluster networking, and Scupper is a great open source solution which helps you enable virtual application network across your infrastructure. It could be even public cloud, private clouds, or your local clusters. Scupper just ties them into a single thread and behaves that it's a single network across the internet, across globally. So a brief about Scupper. So as I mentioned before, Scupper is an open source Apache 2.0 project. It provides hybrid cloud service interconnect, and it enables location independent communication. So imagine you have an AWS cluster running on US East, and then you have Azure cluster running on Mumbai, and then you have Google or IBM cluster running in Singapore, right? You can connect them, you can you can make the network interconnected to each other using Scupper on a secure private communication network. And any service can connect to any resources across your cluster. It's lightweighted, it's user space and developer deployable, which means you do not need to go to the administrator of your Kubernetes cluster to ask for permission. You as a developer, you as a DevOps person, you can simply deploy Scupper. It's deployed in one namespace or a project. You don't need to kind of expose your services to the public internet, which is kind of secure. And you don't need to change any of your application code. If you're a Golang or a Java or a Python developer, you literally don't need to implement anything at the Scupper level. You will just focus on writing your code while setting up, initializing a Scupper router, and the Scupper router will take care of everything. Right. So, yes, it's a service communication transparently into secure virtual application network. So it forms something called as WAN, virtual application network, which ties up all multiple networking interfaces available. And in this demo, we're gonna use Scupper. So setting the stage here. So how do I deploy microservices application across multiple OpenShift clusters? So that's the task for the day. That's we're gonna do in the next couple of minutes. So imagine we are building an e-commerce company. We are building an e-commerce startup, and we want to have multiple microservices. We have email services, we have ad services, payments, and checkout, front end, product recommendation, and cache and cart and load generator, whatnot, right? So this is our application for this demo, which is a microservices application comprised of 10 plus or 9 plus microservices. Our job as a DevOps or developer is to distribute these application in such this way that we have 3 OpenShift clusters running on 3 public cloud environments, AWS, Azure, IBM, and we need to distribute our workload across 3 environments. So for example, the first cloud will host front-end recommendation and product microservices. The second cloud will host ad, cards, Redis, currency, and checkout microservices. And the third cloud should host email, payment, and shipping microservices. Now, the catch here is that in order for our e-commerce business to work or the application to work, all of these microservices needs to contact or connect to each other. And guess what? Scupper, which needs to be deployed on 3 environments, will make this happen. It will enable the communication across 3 different public clouds, right? So without further ado, let's go and see this demo. Okay, I'm going to share my switch to my, okay, not this one. Yep, this one and maybe this one, right? So we're gonna swap between different windows here because I have so many things to do at the moment. This is the type of repository that I'm going to follow in this demonstration, so that you guys can also follow along, or maybe you guys can take a look at later stage. This repository is open and open for usage. All right, and yeah, so this is the repo we're going to follow, step-by-step instructions. Before we go into that, this is OpenShift environment. If you guys are wondering what is OpenShift, how does it look like? So this is how OpenShift look like. OpenShift gives you a very glossy and a very powerful user interface to interact with your Kubernetes cluster, where you can go and see, hey, okay, tell me how many nodes I have a cluster, right? And so you can manage almost everything from the OpenShift console only. So as I mentioned before, this is Azure cluster, Azure OpenShift OpenShift cluster. This is the second cloud, which is my AWS cluster. If I go to Compute and show you the nodes here as well, you can see the domain also, like OCP AWS RedHat developers.rock. So it's kind of a domain which I own, and these are all nodes from Azure, right? So I have deployed OpenShift on top of AWS, OpenShift on top of Azure, and I'm just showing you, how does this look like. The third one is my my IBM cloud, where you can go and see the domain, the nodes from IBM cloud infrastructure. So these are 3 nodes from IBM cloud, right? So in these 3 tabs here, we have AWS, Azure, and IBM cloud OpenShift clusters. This is the tab which I'm going to use for our project, for our demo, and then this live stream, and then I'm going to switch to my shell terminal just to run the commands. Okay, so I'll clear here, and I'll run a few commands like OC get nodes. So OC is a CLI command tool for interacting with Kubernetes or OpenShift. So this should come back with a response. All 3 clusters that we have. You can already see that it's slightly slower since I'm connecting from my home to these 3 environments. So it's not too bad, right? So for if you want to follow with me along, so that I'm going to use three terminals here: Azure, AWS, and IBM Cloud. You can see the names on the right hand side, so that you will not get lost when I run commands, right? Okay, cool. So let's go step number 1. Let's go and create a namespace. Let's go and create a project across all cloud environments, and this project will be called as multi-cloud. So now assume that all of us who are listening to this or watching to this are developers or DevOps guy. Step number 1 to deploy an application is to create a namespace or create a project. Okay, so look at this one. So this is Arrow. Arrow is Azure RedHat OpenShift, yeah, and this is AWS, and this is my IBM Cloud. So we have created three projects independently on 3 cloud environments. Next, we're gonna do and go set up with the virtual application network. first we'll set up on AWS, on Azure, then AWS, and then IBM, right? So step one is to initialize Scupper. And before I do that, I need to go into the right directory, which is cd git multi-cloud OpenShift multi-cloud OpenShift cloud demo. I think this is the one. Yep, this is the one. Yes, one more thing that I wanted to do is removing the old files, otherwise our demo will fail. Yep, rm. Okay, now we are clean. Verifying. No, I think on this terminal, I still need to. Okay, there's some shell issues. I'm just trying to fix. Yep. So on this terminal, I need to still go into the right directory, which is not here. So coming here, cd. Yes. Okay. Now we're all set.
So basically, we are having the environment in all three clouds, and we are going to manage. So
that is right. Yes. Okay. So I have three different shell open: terminal 1, terminal 2, terminal 3, Azure, AWS, and IBM. What I was doing before is I was switching to my GitHub repository on local, because we're gonna run those shell commands, which will, or YAML files, which are available here. So before, so that's a prerequisite. It's a part of the demo as well, which I'll give you later on. So coming to our instructions. So step one. So I want you to understand the logic here. So that step one is to initialize Scupper, because once we initialize Scupper and create tokens, Scupper will start to set up its virtual application network across three different clouds. So step one is to initialize Scupper on all three cloud environments. So it's a very simple command here. So Scupper init. So we'll do on plus cloud Scupper init OCP1. So OCP1 is my OpenShift container platform, my first cluster. We're gonna run a similar command on OCP2, Scupper init OCP2 on AWS. Okay, not this one. Yep, this was incorrect. So first one is done. This is OCP2 on AWS. And then we're going to run the same command, OCP3 on IBM Cloud. So we are right now initializing Scupper, nothing much. Then we will create a token. We'll create a token on our first cluster and tell it like, hey, 2 more people are going to join you, or 2 more cloud environments going to join you. Okay. All right. So let's create a token on Azure. So it will create a token file, create a token on the second cluster, like, hey, because to set up a secure pipe between the clouds, Scupper will use these secure tokens, and your network would be private. It would not be a public open internet, right? So we're going to create tokens. So token is created. And then we're going to link clouds now. So there are only 3 steps involved in initializing, token creation, and linking. So now we're going to link, hey, please link AWS and Azure using this command, Scupper link create and token file name on AWS side. We'll run this command. It will consume my that we created, and then it will establish a connection between AWS and Azure, right? Because we asked to use token file number 1. Next, on the IBM Cloud, we're going to create links between AWS and Azure. So this should connect IBM and Azure. Will connect IBM and in AWS. Okay, so connection seems to be working. Let's verify the status. Sometime it take a few minutes to establish. So link 1 is active. This is good. Let's see about this. Okay, link 1 and 2 also active. So refreshing here, what we have done right now is we have initialized Scupper on all 3 environments. We have created tokens on the environments, and then we have created links, private links, virtual private links across 3 environments. So at the moment it's a triangle. AWS and Azure and IBM can talk to each other, right? For this OpenShift cluster. So up next is we're gonna deploy the workload. So that's all is needed. So we're gonna deploy our microservices workload. So as I mentioned before, we will have microservices application deployment file 1, which will contain front end, product catalog, and recommendation microservices code, right? So we're going to deploy this on AWS. Oh, sorry, in Azure. So we'll apply this YAML file. So those who are interested, I can also show you, but that yeah, I'll still cat this file. MSA, I think the name is MSA deployment OCP1.yaml. So for the folks who are kind of new to Kubernetes or familiar with Kubernetes, you can follow this file. It's a YAML file that Kubernetes will consume to deploy the resources. So like deployment type recommendation. So it will go and deploy the recommendation microservice, and then it will go and deploy the front end microservice. So as I mentioned, we're gonna deploy multiple services on each different cloud. Okay, so let's go and deploy our first microservices, set of first microservices on Azure. So this is file number 1. We're gonna run same file with on AWS. This is number 2.yaml, and then we're gonna run the same file on IBM Cloud, number.yaml. Okay, so what under the hood is, now Kubernetes is deploying microservices for you. Recommendation and front end is here, and then checkout, cart, currency, and Redis is here, and then email, payment, and shipping is on the third cloud. So now our application is coming up on all 3 environments. So if I do clear and if I do OC get pods, it should show us that application is coming up. Okay, now it is running as well. Fantastic. On AWS. Also, our application is running now on the Azure, and then as well as on IBM cluster. 31 seconds ago means it's just deployed a few minutes back. All right, good. So our application is now up and running. Next is we wanted to enable communication between the applications, which means we need to expose services, and we need to use Scupper to expose the services. So we're gonna run this shell file, which is just 2 commands. I'm gonna show you that as well. So what we're gonna do next is we're gonna expose Scupper expose deployment product recommendation. So we're gonna expose our microservices running on here, so that other clouds can connect to it. If we don't expose, then other clouds do not know about existence of this microservices. So we'll use Scupper expose command to kind of expose the microservice. Okay, so I'm doing this sh. Okay, this is the wrong command. Sh and then script name. So this will expose my deployments. These are exposed now. We're going to do this on the second cloud. Here we go. And similarly, we're going to do this on the third cloud. So we have used Scupper to expose these services. Now, each each cloud can literally see other clouds microservice at the moment, right? And we're gonna just see that in a moment. But before we do this, there could be one issue that we need to also fix. So if I do OC get pods, there would be one microservice which would be failing, which is the known issue at the moment to me. Look at this one. So the cart microservice is failing, right? And a simple fix at the moment is we're gonna reboot the pod. We're gonna reduce it to 0, reducing the replica of this pod to 0, which means like, hey, destroy this pod and maybe enable this once again. So I still need to fix this. What's the core reason? But that's a temporary fix at the moment. So, and the power of Kubernetes, you can scale down your application. You scale down the replica to 0, and you can also scale down to replica to your preferred number. I can have 10 here. I can have 20 here. I can even have 100 here, right? It depends on the workload. So I just rebooted one of my microservice, which is a cart service, and then I'll do OC get pods. Hopefully after this, it should be working fine. Yes. So look at this one. The cart service is now up and running. So our 3 OpenShift clusters are there on 3 different clouds. We have set up the virtual application network. We have set up the e-commerce product application, which is composed of microservices, and everything's good to go at the moment. So now we just need to grab the front end IP address so that we can connect to our business application. So we're gonna go and grab this IP from here. Okay, so this is the front end IP of our application that we have deployed on the cloud. So let's go and see if they're able to talk to each other. So I'm gonna go and open a new browser here, put in this IP, and boom, look at this one. So we have our microservices, an e-commerce, a business application running fine. I'm gonna order some glasses, and then I also gonna order some salt and pepper shakers. Okay, give me 4 for my friends, for all the friends of Cloud and Loud. And we're gonna go and get some mugs also, right? So you can, if you follow along, whenever I'm clicking on any of this interface, it's actually going to call the respective microservice. So if I'm clicking on add to cart, it's going to call the microservice add to cart, right? And I can also show you that part, which is very interesting. And I think that's the last part of the demo. So you can see this, this works, right? Our application is working. We're able to interact with the application. I'm also going to show you Scupper user interface so that you can see, yeah, this is for real. So we're gonna grab the Scupper front end console link from here. We're gonna open this in another new tab, and then we're gonna grab the IP address of the admin. The password is this, and username is admin. Sign in. So this is the Scupper console, and from here you can even monitor the layout of your network. So look at this one. So this is my services layout, and this is Scupper showing you a detailed view. If I go to deployment, Scupper will show you all the deployments. Like, okay, good. You have OCP1 cluster connect and with 3 services. You have OCP2 cluster, and then you have OCP3 cluster. So all of them are connected, and Scupper gives you a nice way of visualizing this, how your interconnectivity look like. And the biggest proof is that you're able to consume and able to use a microservices, distributed microservices app, and which are able to talk to each other. So that's all I have for the demo today. And before I go, I wanted to point you to I'm going to give these links, and the organizer will post these links on the chat. But yeah, if you like to explore more on Kubernetes and OpenShift free of charge, so I can point you to this fantastic resource that my team manages at Red Hat. It's developer.redhat.com, and you as a developer, as a DevOps guy, you can literally go and get your free OpenShift cluster free of charge, and you can use it, and you can follow along interesting exercises which will make you, which will give you step-by-step instruction how to use Kafka, how to deploy Java application on Kubernetes, how to deploy things on OpenShift Sandbox. So that's resource number one. And then the resource number two is learn.openshift.com. It's another great resource on which you can, free of charge, as a developer, you can, learn on a lot of interesting things. You can deploy your own OpenShift free environments and, follow along learning about your favorite technology, your favorite cloud native technology, whether it is CI/CD, GitOps, or, whatever, or Knative or Java or Python, right? So it's interactive, highly recommended for people who really want to get their hands dirty with OpenShift and Kubernetes. Try out these two links. I'm going to give these links to the organizers so that they can post this after this call. And I think um, with that, I want to shout out to these are the links which I'm going to give you guys. And with that, thank you so much for listening to this talk, or whenever you listen to this talk. So over to you, Vijay, if there are any question or if
Thanks.
there are any clarification that you wanted.
Yeah. Probably, as you mentioned, future is going to be hybrid. So we are not going to be
Hmm.
in one single cloud. So OpenShift is going to play a huge role in all our technology.
That's
So
right.
I'll collect all the information. So probably I can give back to the community. Even there are many people sessions they are arranging it. So probably
Hmm.
I'll also touch base with you. We will conduct a dedicated some use case based more in upcoming conferences. So that will help back to the community. Thanks for your time, Karan.
All right. Thanks for having me, Vijay. And fantastic. All the best.
Yeah, thanks.
Bye.
Bye.